Hello, Flat Earth researchers, debaters and debunkers. In the history of our modern science that tells us the shape of our Earth, no one has actually ever gone out and measured the curvature on the surface. In fact, it's only people investigating flat Earth that have gone out and tried to find the curvature on the surface. Everyone else has assumed that we're on a spinning ball only by looking at the sun, moon and stars. You know, for 2,000, 1,500 years, astronomers were the people telling us that we lived on a globe because of the way the sun, moon and stars move across the sky. None of them actually did any scientific measurements of the surface itself. No one was looking at the shape of our Earth and the mechanics of it all. The heliocentric model has all been dictated by people looking at the stars and watching them go across the sky over and over again. And you get these idiots that come along and say that, you know, the heliocentric model is the only one that can predict eclipses and all that. That's a complete load of bollocks. I mean, obviously, you know, lost civilizations that we know nothing about were building massive monuments and things that line up with eclipses and the sun at certain times of year and things like that. So they knew what was going on. They were watching the stars in the sky, but they weren't necessarily saying that that meant they were on a spinning Earth. So, but, you know, as far as being able to predict things, you don't need a heliocentric model to do that. The heliocentric model is just one description or translation or interpretation of what we see, what we have observed for thousands, maybe hundreds of thousands, maybe millions of years. But nobody ever had to put us on a ball in order to do that. But the point here is that the curvature of the ball that we're supposed to be on and the movement of the ball has never, ever, ever been detected or measured or observed. It's all been done by looking up instead of down. I mean, how scientific is that? No one's actually found a way of measuring the curvature on the Earth. And it was people that are either, well, I mean, the people trying to debunk flat Earth by looking at horizons, and they're just what they're doing. They're watching a sunset and saying that's because the Earth is moving. Well, that's just their interpretation of it. They're not making any measurements that prove what's moving and where it's going. No one's saying, and you can't. As I showed in my vid the other day with a light. You can't look at the stars and first of all, you don't know how far away they are. You don't know what they are apart from them being lights in the sky. Yeah, keeping perfect time. What we do see in the sky is a wonderful synchronistic clock of many parts. One of the first things you have to try to do if you are looking into the flat Earth or trying to work it out or trying to see, at least trying to see how the mechanisms can work, rather than the idea that everything seems to be moving because it's us that's spinning. Each celestial object is doing its thing. And when they're lights, you don't have to come up with, unprovable science like gravity based on mass to say how things move. If they're just lights in the sky, well, there's a million ways you could probably get to do that much easier than trying to move big balls of mass around, So when you look into the flat Earth, if you have a discerning mind, if you can be aware of your attachment to the globe, then you can think about and perceive how each celestial object is doing its own thing. So the sun goes around and around and it hits a certain height or diameter of its circle at certain times of the year. You know, so it's doing these concentric circles and going up and down like a corkscrew. I mean, it makes sense. Makes sense for the seasons, and any argument or excuse that anyone comes up with that, well, you know, the sun should shrink in size or this or that. You know, the sun, we don't have anything else to compare the sun with. Yes, we can look at it as in terms of perspective, and it does shrink if you are able to see it long enough, but the horizon in front of us is what cuts it off, and it doesn't have to be a globe that cuts it off. It's just the surface, as far as we can see across the surface, to the point beyond which we cannot see anything anymore, apart from, and not even light. It's really not that difficult to perceive. So the sun is doing its thing, and the moon appears to be doing something in tandem with it, creating this duality of night and day, of the different kinds of light, the kind of the nurturing light that the sun has, and the kind of what do you call it, the it's a lesser or a kind of opposite kind of light that the moon seems to have. Shout out to Jazz Sinclair, by the way, and your twilight musings. Yes, and I was thinking about that the other day, that, you know, dawn and dusk are not the same thing. You know, you can, of course, you can say that it's the Earth spinning round and the sun goes up and down, but it's different, isn't it? You don't get the same colors, you don't get the same feeling. Yeah, there might be scientific ways you can explain what's going on in the morning as opposed to what's going on at night after a day of sun, but they just feel different. Dawn and dusk, or dawn, yeah, dawn and dark. So again, we go, you know, the more you think about it, the more you realize that the whole globe, the movement of the globe, the spin, the orbits and all that stuff, I mean, that's why these ridiculous speeds, it doesn't matter how much of a revolution that is because of the size of the thing, it doesn't negate the fact that you're traveling at a certain speed. And really, you know, when these people come along and say, imagine you're on a train and you throw a ball, oh god, well, all you're saying is just the same as us not moving. You're just making an excuse for us, for the assumption that we're moving, but not able to feel it because there's no acceleration or deceleration. It's a constant speed. But, you know, when you go around a corner, you feel it. Yeah, and if you want to apply Newton's laws, or then, you know, if the Earth is whizzing through space around the sun at what, 66,000 miles an hour or something like that, then if you're spinning, if you're at the front of that orbital motion on the Earth, then you're going to be pressed against the Earth. If you're then, the Earth then spins and you are in the drag of the Earth, you can then be left behind by the Earth, so you would be lighter. Of course, you can come up with the excuse or reason that you know, it's all so slow and gradual that you don't feel it, and it doesn't make any difference, and blah, it's only a soon 0. I'm speaking Thai, 0.0 whatever percent, whatever. That's the thing, it's all mathematics that isn't measured at all. It's just calculated. And then, you know, you've got people looking at, you know, the horizon, and of course, when you get high up, you don't get a clearly defined horizon. I've parked up, let me turn this around. Yeah. So when you, hang on a minute. Whoop. Let's try and get this right. So when you, is this on? Is this on? So when you Damn, lost my train of thought. Oh, it's going on. Yeah, just the shape of the Earth has never been measured by measuring the surface. Right, on with my rant. So this is very, very important that we recognize and we understand that all the assumptions about the Earth being a globe and it moving, spinning, have been made based on looking up at the sky, up at the celestial objects. And of course, what hasn't been taken into account at all is perspective. This is why perspective is so important to understand, because, you know, when you understand that all the illustrations of the heliocentric model are illustrations of, you know, mathematical solutions based on circles, based on geometry, and of course time. So just like a clock face, you know, a circle, the geometry allows you to illustrate this passage of time that we are seeing with the sun, moon and stars. But it's not a passage of time because we're moving. It's a passage, they each have their own role to play in telling the time in their way. Yeah? I mean, okay, we're in an intelligently designed system. That's just so obvious. You don't need to, you know, so obviously it can work any way that the intelligent creator desires it to. But the way we interpret it is obviously up to the individual. That's an objective reality, if you like, for each person. But the thing is, we're told that is, hang on, did I get that right? Subjective reality. But we're told that it is, you know, everyone's absolute objective reality. Yeah, so, you know, by just looking at the sun, moon and stars and telling the time, which has been done for thousands and thousands of years, predicted by many peoples apart from us, we didn't suddenly just gain this superior insight. And, you know, Newton's theories on gravity just to try and materialize the big clock in the sky and try to tell us that is your truth, that is your reality. You can't argue it because you can't argue with maths. Well, yeah. Show us the maths of the actual measurements of the curvature along the surface of the Earth. You know, and it's like, so this is it. Once you, so the realization that it's flat earthers will understand the word, using the word realization, because it's not like we suddenly jumped on the flat earth bandwagon. We heard about it, maybe heard an interview or watched a video or whatever, and started thinking about the whole thing. And it's an incredibly intense process, because all of a sudden everything you thought you knew that's tied into the heliocentric model suddenly comes into question, because you can see that there is truth in the fact that the horizon's always at eye level, or the surface is always flat, and the way we see things is that the surface and the sky appear to meet at our eye level. And of course we all know that instinctively. It's just one of those things because we use our eyes all the time. But for the mathematician who enjoys or likes the geometry that, or is that way minded, then they will have a picture in their head of these mathematical formula based on the passage of time and geometry that have been put forth as the truth, our physical reality. But of course, to the mathematician, it makes complete sense and is explainable. But for anyone with a discerning mind, not just a flat earther, but anyone with a discerning mind, you can quickly see that there are many, many excuses and, you know, oft-used reasons for things about the heliocentric model which, you know, should or shouldn't work and therefore seem a bit out of place. But there's always some kind of explanation, some compartmentalized explanation. So of course, when you start looking into it a bit more deeply and trying to establish the big picture, because of course you start arguing with globe Earth defenders, and they've got their very compartmentalized answers to every little query, and these are just, you know, again, assumptions or things that can't really be explained if you insist on fitting things into a heliocentric model and saying that, you know, it all gets driven around by mass attracting mass, blah, 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 blah. So it's all these little bits and pieces have been put together. But when you try to look at the big picture, it doesn't all fit together. So really, what's the big picture? The big picture is that we see the stars, sun and moon moving across the sky. They keep time. The sun has a job of kind of doing the seasons, and the moon tells us very clearly the passage of time throughout a month. And, you know, so you don't have to come up with all these different lengths of days and terminology that ends up kind of being another word you have to use. Well, oh, there's sidereal days and there's this days and there's a north pole, but then there's a magnetic north and there's a true north and all this stuff. Yeah, it's just all this double speak for this artificial construct that's been put upon or forced upon what we actually observe and experience. So of course you can know the story very, very well. You can know all the excuses and the reasons, and you can rattle off the figures, but it's all about calculations, isn't it? You know, and this is the difference between science. Real science is making observations and measurements and testing, and yes, you have a theory, you put it to the test, but of course there's a limit to how much we can test what's actually going on up in the sky, in the stars. And of course, if people are telling us, well, we've got spaceships going and having a look at these stars and planets, so we can tell you what they are. Oh dear. It's such a significant aspect to our lives, yet some jokers who don't care what kind of effect it has have just seen ways to make money, you know. So they know that they can bounce signals off the atmosphere, well, I hate calling it that because it's not a sphere, the air, different layers in the air, and then so then they come up with satellites, and they know that they can just establish the belief that there are satellites and do everything else by bouncing signals off the ground, from the ground up to the stratosphere or ionosphere or whatever, back down to where someone thinks they're picking up a satellite signal. And of course, you know, they get some university students to build some contraption that will you know, have this device, that device on it. Oh, we're going to measure solar particles and what have you. So, you know, these physics buffs come up with are told to come up with some you know, instruments to stick on a box and cover with foil. They get some money. They believe that their thing is going to go up there into space, and all the while the people who have been funding the project know that they're going to get bucket loads more money from just you know, things like the information, selling on the information. It's a mug's game. But that's the thing, they've taken it, you know, they've had to kind of like instill the belief as well that this this stuff is going on. They're actually doing this stuff. Things are spinning around our globe, but we've never ever seen that. Oh dear, it's funny. Anyway, there you go. That's my little rant. So just remember that no one has ever measured the physical curvature of the surface of the Earth, and it has been flat earthers who have been looking for the curve, still not found it.